So this video is going to introduce what to do if you have variables on both sides of your equal sign. And the main idea is it's going to use a lot of the same inverse operations and doing things to both sides, but how you get started is you want to move all of your x's or whatever variable you're working with to one side of the equal sign. So let's say that I want to move all my variables to this side of that equal sign. That means on my equation, I have to think of how I'm going to get rid of this 6x from this side and move it to this side. It's going to be very similar to how we would get rid of this plus 7 if we were solving this two-step equation here. Since it's positive and I'm adding it, I want that to go to 0, so I would subtract a 6x. Now I have to do it to the other side as well. And by doing that, I can see that a 6x minus 6x, that would cancel, leaving me with just a 7 over here. And then the other side, that 13 is still there, but now my x's can combine, combining like terms. 7x minus 6x would give me a positive 1x, or just x. So now that looks like something I'm used to solving. I have x, I still want it by itself, and right now it has that 13 that's being added, so I want to get rid of that. To do so, I would subtract, and I can see that that would give me an answer of negative 6 is equal to x. Now, if you wanted to, you could check that by plugging that value in for x on both sides of the equation. So a 6 times negative 6 and then plus 7 would give me a negative 29. And I'm hoping that by doing 13 plus 7, and again times my answer of negative 6, and it turns out that also gives me negative 29. So that's how I know that answer is correct. I get something that really is equal on both sides. So up next, we're going to look at, does it matter what side you move it to? As a quick recap, we chose to move this 6x over to this side of the equation. So I subtracted 6x from both. So next, what we're going to be looking at is, what if we chose the other side? Is that wrong, or is there a better way to do it? So now we're going to look at moving all the variables to this side of the equation. So I would start by wanting to get rid of that 7x. Since it's positive and then adding it, I would subtract a 7x from both sides. So now 6x minus 7x would give me a negative 1x, or just negative x plus 7. And over here with those canceling out would just be 13. So next I'm going to get rid of my addition or subtraction, so subtracting 7 from both sides. And I have a negative 1x is equal to 6. So it looks like I'm finished, but I still have negative 1x. So I would finish this off by dividing by negative 1. And we see that we get an answer of x equals negative 6. So the good news is it does not matter. You can see that we got the same answer here regardless of which way you did it. Normally what's going to happen, like we can see here, moving it to one side might give you a negative to work with, as long as you know how to get rid of that at the end, whereas one side I did not need to worry about that. So it's just a matter of kind of going with your gut, because it really does not matter which side you move it to. So maybe at this point you feel like you have a pretty good grasp on it. I'm going to go through a couple other examples that are a little bit different. So if we look at this first example, the main difference is we have this minus x's on each side. But again, I'm going to start the same way of kind of picking a side to move them to. I'm going to move all my variables to this side. So that means I need to kind of get rid of that minus 4x. So to do so, I'm going to add it to both sides. So I would still have a 13 over here, and then a 1 plus 3x now after combining my like terms. Negative 1x plus 4x is where this is coming from. So now I get rid of my addition and subtraction. So I'm going to get rid of that constant of 1 first to give me 12 is equal to 3x. Then I'm going to get rid of my multiplication by using division and getting an answer of 4. So this one's slightly different because my first step was adding a variable to both sides. And you can see I chose this side because I knew that that would combine to a positive. If you chose to move this, you would have a negative 3x to deal with, but you would still get that same answer of a positive 4 in the end. One more example, this one has a little bit more going on. So just like if you were approaching a multi-step equation without variables on both sides, you always want to start by seeing if you can simplify one or now both sides. So if I look over here, I see that I have some like terms. So before I worry about moving variables or doing things to both sides, I want to first simplify that. So I'm going to combine those like terms. Negative 7x minus 3x would give me a negative 10x. still have that plus 2, and then the other side did not need simplified at all. So now I'm ready to solve. As far as choosing what side to go to, I know I'm going to be adding both, so I can see that if I add a 10x, that would give me positives to work with. So that's what I'm going to do. I'm going to add a 10x and move all my variables to this side. So I still have a 2 over here. Combining like terms would give me a positive 2x, and then I still have that minus 8. So now getting rid of my constant, I would add 8 to both sides, giving me 10 is equal to 2x. Then if I undo that multiplication by using division, I get a final answer of 5.